Welcome to your students. Today our topic is reflection of sound waves and echoes. So first, we will get to know what exactly is the reflection of sound wave, how sounds are reflected. So basically, it's very much similar to the reflection of light, except that light is a transverse wave and sound is a longitudinal wave. That's it. The sound wave, the incoming wave, the incident wave you can see here, this is the incoming sound wave. Don't get confused with this arrow. This just shows the direction of the incoming sound wave. Okay, this is the sound wave, the incident sound wave, which when falls on a certain barrier, you can see there is a barrier here, it will get reflected with the same angle as that of the incident wave. You can see the angle of incident is equal to the angle of reflection. Here is the incident wave. It strikes the barrier and it bounces back with the same angle. This arrow shows the direction of this wave. Remember that this part of the wave which is most closest to this arrow is the wave front, the front part of the wave. So wave front is basically the front, or the, you can say, the first part of the wave, the first you can say crest or trough of the wave. Okay, so this is how basically the reflection occurs in sound waves. Remember that hard and smooth surfaces reflect much more and absorb very little part of the sound wave, such as any shiny ball, any surfaces which are curved, any hard surfaces like floor or walls. They reflect much more than they absorb. But the surfaces which are soft and edgy absorb much more and reflect very little part of the sound wave. The surfaces which are soft like cushions or sofa or bed or clothing or curtains, etc., or which are edgy like edges of the wall, the edges of a table, etc., are the surfaces which absorb much more and reflect very little part of the sound wave. This was all we needed to know in the reflection of sound wave basically. But echoes are something that are application of the reflection of sound wave. So before actually discussing the echoes, I must say I have to discuss reverberations also. So besides echo, we will also discuss reverberations because these two are basically related to each other. Echo is a special case of reverberation. In reverberation, we see that when we let's suppose I've just made this image here. It should be here. This is for reverberation, and this one is for echo. Okay. So in reverberation, what happens? Let's suppose a room. A person here is standing here. Now, if a person shouts hello, what happens in an empty room? The sound wave just strikes the walls and bounces back very fast. They strike the wall and bounces back. Strike the wall, then bounces back, then strikes this wall, then bounces back. Strike and bounce, strike and bounce, strike and bounce. This happens really fast because the space available here is very short. So the original voice gets bounced back so much time in very little span of time. While if we see the case of echo, take an example of a person standing on a mountain and yelling hello. Okay, so if he says hello, this sound wave will go in this direction, and will strike this mountain which is far away from this person. Okay, will strike this mountain, and in turn some part of the wave will bounce back to him, and he will again hear his own voice. But what exactly is the difference between this voice and this voice? As you know, this distance is much more than the distance of the room. So, when this sound gets reflected back, the brain cannot differentiate between the original sound and the reflected sound. Why? Because the time interval between both sounds is very short, so that the brain cannot distinguish between these two sounds. While the time gap between these two sounds is much higher as compared to the reverberations. So the brain can easily distinguish between the original sound which was produced and the sound which was reflected back to the person. Okay, so the reverberation the sound persists for some time. In this case, the person will hear many reflection over and over and over again, so that he will not be able to distinguish between them. So what happens? He will hear a longer sound, a longer his own longer voice without gaps between them. But in echoes, there will be gaps, and he can actually distinguish between the reflected sound and original sound. In reverberation, the sound persists for some time, while in echo, the reflected sound is heard as a sound distinct from the original sound. Now you get it? Another point is, there is no condition of minimum or maximum size of the room. This is for the reverberation. Okay? There is no condition for the minimum or maximum size of the room. It is present in every room. The room you're sitting right now, every room you have ever been in, it actually exists in every room, in every closed room you can think of. And echoes for distinct echo. Minimum distance of reflector should be 17.2 meters. If the distance between the person, the source, and the reflector is less than 17.2 meters, you will not be able to hear the echo because the brain would not be able to distinguish between the two voices. Okay, so the minimum distance of reflector should be 17.2 meters. In this graph, you can definitely understand it from this graph. This is the case of echoes. A person standing on a mountain yells hello and hears his voice like this: hello, 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 like this, starting from the highest intensity to dropping down to the lowest. But what happens when a person is standing in a room and he then yells hello? He will not be able to hear distinct voices. He will hear just one hello, but this hello will be much longer than the original one. So, person standing in an empty room will say hello, but he will hear hello. Now you get it? This is the difference between reverberations and echoes. So that basically the difference is of the time gap. The brain cannot distinguish between short time gapped sounds, while in case of echoes, which is a special case of reverberation, the time gap is much higher. The person will be able to hear his own voice repeatedly. Okay, so how much time should be passed for the echoes to exist. So if the time lapse is less than 0.1 meters, it is reverberation. And if it's more than, it should be seconds. 0.1 second, it should be the time lapse. If it's less than 0.1 seconds, it's reverberations, and if it's greater than 0.1 seconds, it is echo. Coming to the end, here we can also determine the distance between the original source and the reflector. Here is original source and the reflector. We can determine what is the difference distance between them by using the relation v equals to 2s. Why 2s? Because 1s for reaching this reflector and 1s for reaching back to the sound producer, or you can say this person standing over there. Okay, so this 2s divided by del t. Del t is the time taken for the voice to reach this mountain and to reflect back. Okay, it will be the time t. Now what would we do? We will simply, if this del t is getting divided over here, we can take this del t over here and multiply it. We will get v del t equals to 2s, or we can write it as 2s equals to v del t. We don't want this 2 over here, we just want to calculate this s, so we will just, if it's getting multiplied over here, we will just divide it over here. S equals to v del t divided by 2. This is how basically we can determine the distance covered by the sound wave in case of echoes. Good day, everyone.